All right, let's try this question. A person jumps off a chair. During the downward motion, the blank pulls the 50-kilogram person downward with a force of blank. What is actually pulling the person downward? Now you might say gravity, but that's not an object. What is the other object that's involved? Again, the key to N3 is figuring out what the two objects are. Well, the object is the Earth. The Earth pulls the 50-kilogram person downward with a force of what? Well, it's a force of how much? 50 kilograms times 10 meters per second squared is going to be 500 newtons. All I did was I just measured what mg was. That's the force. Now, what is the N3 reaction force for the force of gravity Fg on the person? What's that reaction force? Well, if it's the Earth pulling on the person, here's our person falling, okay, and they have not hit the ground yet. They're falling. The force on them is mg down. What's the reaction force? Well, there's another object right here, the Earth. There's a force up on that. It's the force of the person on the Earth. Not when they land, it's while they're falling. It's upward, and it's got, if this is 500 newtons, this magnitude is also 500 newtons. The Earth is actually accelerating up, albeit very, very small acceleration when you fall. It's the force of the person on the Earth. In this case, we're just talking about gravity. You pull the Earth up while the Earth pulls you down. So those two forces are equal and in opposite directions, again, on two different objects. All right, let's deal with a very common misperception here. One where an object is sitting on a table. So let's draw an object of mass m. And it's sitting on a table. And I'll just draw the table in with a dotted line so we know where it is. You don't need to draw the table in. Usually you don't with a free body diagram. But we've got, it sits motionless on a table, so we know that there is a force of gravity pulling down on it with mg. But it's not accelerating down. There must be another force. It's the force of the table, which I will symbolize with the symbol N. That is the normal force. Again, the normal force is a force exerted by a support surface, which is always perpendicular to the surface. Ropes pulling up, that's not the normal force. The force of air drag, even if it's up, is not the normal force. It's always a support force exerted by a surface. Now, are these two forces, assuming this is motionless, are these equal and opposite? Yes, they are. They're the same magnitude and they're in opposite directions. Are Fg and Fn, which I've symbolized with a little n here, are they a Newton's third law action-reaction pair? Think about that. The answer is no. Why not? Well, they act on the same object. They cannot be an action-reaction pair. They act on the same object. So that cannot be an action-reaction pair. Does that mean that Newton's third law doesn't apply here? It's got to apply. It's a law. So we got to figure out what the objects are and what the forces are that are involved with Newton's third law. So let's try this. What's the Newton's third law pair for the force of gravity? Again, the clue is, or the key is, to figure out what the two objects are. Fg is the force of what on what? Fg is the force of the Earth pulling on the brick. It's pulling down with force mg. So that is, that will be the force of the Earth on brick. The brick will pull upward on the Earth with the same force that the Earth pulls downward on the brick. So the Newton's third law pair is the force of the brick on the Earth. That is the force of gravity. The brick is pulling upward on the Earth. What's the N3 pair for the normal force, which again I've symbolized with a little n? Hint, you got to figure out what the two objects are. The normal force is the force of the table on the brick. The Newton's third law pair for the table on the brick, well, that's easy. It's the force of the brick on the table. The brick is pushing the table down. And if the legs can't handle it, the table will collapse. There are always exactly two objects in a Newton's third law reaction pair.